Hello student, in this video we are looking at the remainder and factor theorem. This is like nothing very new. It's like when I have 9 divided by 2. When I divide 9 by 2 once into 9, I get 4 remainder 1. That is what we are dealing with, but then we are dealing with the remainders and factors of polynomials. So if the remainder on a polynomial is required, we usually do this by long division. If you require a remainder on any polynomial, for example, allow me just give an example. For example, if you say find the remainder on x power 4 plus 3x cubed minus 2x squared plus 5x minus 2. Find the remainder on this guy when it is divided by x minus 3. When it is divided by x minus 3. So how do we do that? We use long division. So I have my divisor, I put it there, then what is divided, I put it under the division. So I have here x power 4 minus 3x cubed minus 2x squared plus 5x minus 2 here. Then I'm dividing that guy by x minus 3. So what I do, it is the x that divides here. You just maintain the 3, the x into this guy. So x power 4 divided by x is x cubed. Then I multiply back. When I multiply back, I get x power 4 minus 3x cubed minus minus 3x cubed. This is a plus, minus 3x cubed. So I can subtract. When I subtract, I get 6x cubed minus 2x squared plus a 5x minus 2. So again, divide this guy, the x, dividing this guy, this one, so that I have, this is going to be a plus, I think it is a 6x squared. So I multiply back, I get 6x cubed. And then this guy times this one, this I think it's a minus 18, minus 18x squared. Then I can still subtract. If I subtract, I get a 16x squared, then plus a 5x minus 2. I'm again dividing this one by this guy here, so that I have this as, I think, a positive 16x multiplied back 16x squared. Then if I have a 16 here, a 16 here multiplied by an x is what? Is it a 48? I think it's a 48. So this is going to be a negative 48x. Then I still subtract in here. This minus, I say 53x, I think, minus 2. We again divide because the x is still there. X to the same power. I see this goes to a 53. So this is plus 53 multiplied back. This is 53x, then minus, let me see, I see a 9, I see a 15. Is it something like that? Yeah, 159, I guess. This is 159. So that if I subtract now here, I get this minus that. This is a positive 1, then 157. Yeah, 157 as my remainder, meaning that therefore the remainder is 157. The remainder is 157. So on the polynomial, this guy that we've got up here, we call it the quotient. This guy is the quotient. The quotient is x cubed plus 6x squared plus 16x plus 53, though it was not required. And then this guy, we call it the divisor, meaning my divisor is equal to x minus 3. In other words, we know that if I get the divisor times the quotient plus the remainder, I go back to my initial to my initial polynomial. In other words, therefore, the polynomial can always be simplified in terms of the divisor on x, if I call it the d on x, multiplied by the quotient, if I call it the q on x, plus the remainder on x, if I call it r of x. It is the divisor on x, the divisor times the quotient plus the remainder. That is going to be my polynomial. That is always my polynomial, divisor times quotient plus the remainder. You can try out any other numbers. There are very many in question banks of UNEP that require us to get such simple algorithms. So student, there is something peculiar and interesting that you need to look at here. If I get the divisor, which is x minus 3, if I equate it to 0 to get the value of x, I get x is equal to a 3. If I get this value of 3, this value, and I put it in here, if I put it in here, it will always give me the remainder. In other words, the f of 3 into the function, if I had called it f of x, the f of 3 in here, it will give me 157. You try it out. Plug in here 3, 3, 3, 3. It will always give you the remainder, which is 157. In other words, in this context, the f of 3 eliminates this part and only will remain with r of x. The f of 3 just comes and eliminates the divisor times quotient part and gives me the remainder. So if we move to the factor theorem, what is a factor? If I have maybe 2x plus 4, if I factorize out a 2x plus 2, it means 2 is a factor. It means that 2 is a factor. In other words, if maybe x minus a is a factor of a polynomial f of x, if x minus a is a factor, if it is a factor of a polynomial f of x, you're there. Then if it is a factor, then the f of a is equal to 0. This is what we call the factor theorem. This is simply the factor. This is the factor theorem, that if this guy is a factor, then the f of a, when I get the x is equal to a, then I plug in the value of a here, it will always give me a 0. So let us do some examples of the general scope. Some examples. Yeah, so we have here an example that you find the remainder when x cubed minus 3x, plus 3x minus 4x is equal to 0 when it is divided by this guy. So it is like the x minus a. So as our solution part, I can consider x minus 1 is equal to 0, such that I get my x is equal to 1. So I know that the f we've talked about is that the f of 1 will always give me the remainder. In other words, in this expression, if it is f of x, if I consider that my f of x, it is the one that is equal to x cubed plus 3x squared minus 4x plus 2. The f of 1 into this guy here will be a 1 cubed plus 3 into 1 squared minus 4 into 1 plus 2, such that our remainder is 2. Maybe try out this one, that you find the remainder when 4x cubed plus 6x squared plus 3x plus 2 is divided by 2x plus 3. Try out that. You find the remainder when this guy is divided by that, but the same algorithm. Equate this to 0, get the value of x as negative 3 out of 2, I guess. Plug it in there, you'll get your remainder. So we have here another question, that when the expression x power 5 minus 4x plus ax plus b is divided by x squared minus 1, the remainder is 2x plus 3. Find the values of a and b. It is a very simple number. So from what we've talked about, if I let my f of x, my polynomial, be a function f of x, that is x power 5 minus 4x squared plus ax plus b, you're there, such that I know that if I have f of x, it is always equal to the divisor on x multiplied by the quotient on x plus the remainder on x. So my divisor is this guy. My divisor is x squared minus 1. This is x squared minus 1 times the quotient on x plus the remainder on x. But then look at this guy. This is the difference of two squares. There is x plus 1 and x minus 1, meaning my divisor has been given as x plus 1 and x minus 1 times the quotient on x plus the remainder on x. And remember that if I equate this guy to 0, so that I get the values of x, I know that I have there my x as equal to 1, and then I have x is equal to negative 1. When I plug in these values, the quotient on x and the divisor, they go to 0 automatically. You're there, meaning that the f of 1, if I take the f of positive 1 here, I put it in here, it should equal to this expression. So the f of 1 in here should equal to the expression this side when I plug there a 1. But then the remainder is 2x plus 3. This remainder is 2x plus 3. So I have that from the fact that x power 5 minus 4x squared plus an ax plus b is equal to the x plus 1 into x minus 1, the quotient on x plus 2x plus 3. If I put in here 1, I'm going to have 1 minus 4 into 1, this is 1 power 5, and then plus a into 1 plus b will equal to, I put in here 1, this is going to be a 2 into 1, this guy goes to 0. When you put here 1, this goes to 0, and then 2 into 1 plus a 3, such that I think this is a 5. So I have my a plus b. I take the negative 3 the other side. When I take the negative 3 the other side, what does it go to? If I take the negative 3 the other side, let me see. Yes, so if I take the negative 3, this is a 5 plus the 3, that goes to an 8. Then I can still get the f of negative 1. I put in here, this is going to be negative 1, this is going to be a negative still, this is going to be negative 1, because it is 1 to power and negative 1 to power an odd power. And then this is going to be a positive 1, meaning minus 4, and then minus a plus b will equal to a negative here. This is going to be negative 2 plus a 3, such that I have a negative. I get this as negative 5. Take it the other side, I see a positive 1. So I have negative a plus b will equal to, this is a positive 1 plus a 5 from this side, so that negative a plus b will equal to a 6. If I add these two guys together, if I add this one and this one together, the a is eliminated, so I get that twice b will equal to a 14. Divided by 2, my b is equal to a 7. I can come in and I get the value of a, plug in here b, my a plus 7 will equal to an 8. I take this guy the other side, my a is equal to 8 minus 7, which is 1. Therefore my a is equal to 1, and my b is equal, this one is b, my b is equal to a 7. It is as simple as that. Try to follow through slowly. So let us do more examples in our next video, and then introduce the discriminant. Otherwise, you are reminded to subscribe to our channel, like this video, such that we can create much more math.